Testing the V1 saliency hypothesis by a V1 model, Part 7. Let's do some reflections from our V1 model. First, it's possible to build such a model to achieve simultaneously the following. One is to reproduce the contextual inferences observed physiologically in real V1. And the other is that the model responses can highlight visual locations where visual inputs deviate from homogeneity without hallucinating inhomogeneous responses to homogeneous inputs. This model's behavior, interpreted by the V1 saliency hypothesis, is consistent with many prototypical saliency effects observed in human visual behavioral data. To achieve this without violating these 2 points is not trivial. The finding that a single V1 model can satisfy all of them simultaneously is a support to the theory ViSH. This V1 model also confirms our intuition that iso-orientation suppression is behind many saliency effects for visual textures, which are oriented bars in all kinds of spatial arrangements. Such textures evoke typically the most non-trivial saliency behavior, so our model focuses on such visual inputs and have so far ignored other visual input features such as color, motion, and spatial scale. Although the model has only neurons responding to simple input bars, it can signal saliency at locations of complex shapes such as ellipses, circles, and crosses. One can imagine even more complex shapes, for example, faces. The saliency mechanisms in V1 can lead to side effects, as manifested in real V1, and these side effects can be understood by our V1 model. We can extend the current model by adding neurons not tuned to orientation. Their respective fields have isotropic shapes, such as a large center-surround shape. We can also include model neurons that are tuned to features other than orientation, like in the real V1, such as color, scale, motion direction, ocularity, disparity, and combinations of the features above. With these additional feature dimensions, the model should extend iso-orientation suppression to iso-feature suppression. The V1 model helps us to investigate the V1 saliency hypothesis, which itself is inspired by neural data about V1 and psychological behavioral data about visual saliency. This V1 model, in its current version, is still quantitatively inaccurate. While a model can be used to build confidence in a theory, the theory should be able to stand despite a model's inaccuracies, or fail despite a model's fit to many details. The V1 saliency hypothesis should be ultimately tested against experimental data.